This is going to be kind of fast and maybe not as neat as you're used to, because the first video I made, for some reason didn't post, and I can't repost it, so I'm having to redo this very quickly. Let me get my pen here. All right, so we've been talking about trig in right triangles. What we're still gonna do that today, but we need to introduce some new terms. And when you think about angles, you first learned about angles in geometry. It was defined as two non-collinear rays that share a common vertex. What we're going to be looking at now is angles in standard position on the XY axis, on the coordinate system. So you can see in this picture here on the left, you have an angle. Of course, the point where the two rays meet is the vertex, that's your corner. And then you're going to have what's called the initial side and the terminal side. So the initial side is where you start your angle, and you can see the arrow showing the direction to get to the terminal side. And that's where the angle stops. So what standard position means is here in the picture on the right, well, I did not mean to write, I meant to move the screen up. This is in standard position. And like I said, I don't have my little tablet or a stylus. I'm using my finger. So sorry that it's going to be a little sloppy. Okay, so standard position, and you can see that in this image, the initial side is on the positive x-axis, and then your vertex is at the origin. Okay, so those are those two stipulations right there for it to be in standard position. So the initial side along the positive x-axis and the vertex at the origin. Okay, now you also in geometry only worked with angles up to 180 degrees. 180 degrees was a straight line, and in the positive direction. But here in pcal, we're going to be looking at lots of different size angles. There's no limit to the size that the angles can be, and they can also be positive or negative angles. So when we're in position, you can see, I get red and green for positive and negative here. Okay, a positive angle is going to go in the counterclockwise rotation. So from your initial side, you go in the order that the quadrants are named. Remember, this is 1, 2, 3, 4 are the quadrants. So if you're going in that direction, which is counterclockwise, you're measuring a positive angle. And you can see this angle went to quadrant 3, went past 180 degrees. It's bigger than a straight line. Or in the negative direction would be still starting at your initial side, but rotating clockwise to the terminal side. That's a negative angle. And that is a negative angle that's more than negative 180 degrees. Okay. All right. Now this little symbol right here, that is an alpha. That's another Greek letter. You'll have seen theta, and now you're going to see alpha. We're going to use alpha as the variable for our reference angle. Okay, so reference angle is the distance from the terminal side of your angle to the x-axis. Okay, so wherever you are, wherever that terminal side is, it doesn't matter what quadrant it is, the distance from the terminal side to the x-axis is the reference angle. And it's to the nearest side of the x-axis. So if it's to the negative side of the x-axis or the positive, that doesn't matter, but the nearest x-axis. So you can see here in this graphic, it shows angles in all 4 quadrants. And you can see in quadrant 1, this angle, theta, this is the terminal side. That is the reference angle. The angle itself, theta, is also alpha. So in quadrant 1, your angle measure and your reference angle are the same. So you can see right here, it says they're the same. Okay, but in quadrant 2, your terminal side over here, you're closer to the x-axis right here, and you can see where it's marked as alpha in that red, because you're closer to the negative side of the x-axis. So theta is this obtuse angle, and the reference angle alpha is this acute angle. Your angle is in quadrant 3 here. You can see the alpha is marked in red. That's going to be that acute angle. And your theta is more than 180. So notice how calculating that switch. So you do your full angle minus the 180 to get what was left for the reference angle. And then when you're in quadrant 4, more than 270 degrees, it's almost a full circle, which would be 360. So to calculate that reference angle, you do 360 minus theta. And what's left is your reference angle there. So what that means is your reference angle is always between 0 and 90 degrees. It will never be more than 90 degrees. It would be 90 degrees if you were actually on the y-axis here, because then you would be in either direction, to the negative side of the x-axis or to the positive side of the x-axis, you would have a 90-degree angle. Okay, so that, I'm going to get rid of that. But that's why your reference angle is never more than 90 degrees. And if you were on the x-axis, obviously you'd be 0 degrees away from the x-axis because you're on it. So it's between 0 and 90 inclusive, and it is always positive. Your reference angle is measuring a distance from the terminal side to the x-axis. It's always a positive measure. So there won't be any negative reference angles. All right, so just a quick practice in sketching. Let me get these to the right size. All right, so 300 degrees, think about your quadrants. We know that if this is 0, where we're starting, because we start our initial side at the positive side of the, okay, this is a positive 300. So going in the positive direction, that would be 90. This would be 180. This would be 270. And then all the way back around to where we started, this would be 360 again. So 300 is between 270 and 360. It's actually going to be a little closer to 270. So I'm going to sketch my terminal side a little closer to the 270. So there's my initial side and my terminal side. And again, I'm sorry this is kind of sloppy. Hopefully y'all can do it a little neater in your notes. And then that's not done. That is not a complete drawing or sketch of an angle. You have to have an arrow showing the direction, because this terminal side, actually, if we went in the negative direction, that's an acute angle. We need to show that it's in the positive direction, 300 degrees. So you have to have an arrow drawn showing how you got from the initial to terminal side. So that is a good sketch there. And then I'll label at the terminal side, that's 300 degrees. All right, now negative 120. If I'm going in the negative direction, this is negative 90. This is negative 180. So negative 120 is between those. It's 30 degrees past 90, so it's going to be a little closer to the negative 90, and then I'm going to show that I went in the negative direction to get there and show that arrow. And I will label it as negative 120. Not mean to do that. Come on. There we go. All right, so we'll try here. Getting some sort of notification. I'll make sure this is still recording okay. Best Wi-Fi. Hopefully it's okay. All right, so negative 240. So again, going in the negative direction, this would be negative 180. So this would be negative 270. So then your angle negative 240 would be a little closer to the 270. So it'd be about there, a little more than halfway through that quadrant. And I would have to draw the arrow showing I went in the negative direction to get there. Then positive 120, we said this would be 90 and 180. Okay, so 120 is going to be in that same spot as negative 240. But the arrow shows we got there in a different direction. All right, so that is reference and sketching angles in standard position. And then this one wants us to then find the reference angles. So I'm going to find the reference angle. I'm going to get a different color for this. I'll get orange, I guess. So for the 300, the reference angle would be here, would be alpha. So if I'm at 300 and if I go all the way around, it's 360. So the difference there is 60 degrees. So the reference angle for that one is 60. For B, the nearest x-axis from the terminal side is right here. Come on, draw. There we go. So there's my reference angle, alpha. So I'm at negative 120 for the angle. That would have been negative 180. So the difference from 120 to 180 is 60. So our reference angle here is 60 degrees. And remember, it's always positive. It doesn't matter that we went in the negative direction to get that angle. The reference angle is always positive. For C, it's to the nearest x-axis. So it's going to be this piece right there will be our alpha. So our alpha here, oops, come on, draw, is the 180 to 240. That's a 60-degree reference angle as well. And then here is the reference angle. And that was 120 to 180. That's also a 60-degree reference angle. Okay. All right, now here you've seen the trig ratios in terms of O, A, and H. Now this is actually showing them in terms of X, Y, and R because it's putting it on the coordinate system. So if you have a point X, Y, get a pen here, you have a point X, Y, you plot it somewhere in your, wherever it goes, to what quadrant it should be in. The X value is this, yeah, I just highlighted that wrong. The X value is this distance here, and the Y value is this distance here. And then if you were to draw a ray, the terminal side of an angle, through that point from the origin, that becomes the terminal side of the angle, we'll call that R. And then you can create a right triangle where your reference angle would be, which the reference angle would be right here. So we would use that right triangle there, and we could set up our trig ratios. And we could, if we know x, y, those lengths, we could use inverse trig to find that reference angle. And then we would be able to find the entire original angle theta. So I'm going to do, this has the process written in words of what we're going to go through. So you're going to plot your point in the correct quadrant and draw a terminal side from the origin to that point so that we can see where our angle theta is, and then we'll set up a triangle. We'll use Pythagorean theorem to find the length from the origin to the point, which is our R, and we'll label and use trig ratios. This is a reminder so you understand on what your trig values come out as, positive or negative, because if you're in quadrant 1, your X and Y are both positive. You have a positive, positive. X is positive, Y is positive. In quadrant 2, you go left and up, so it's negative, positive. Quadrant 3, you go left and down, so negative, negative. And in quadrant 4, you go right and down, so positive, negative. So if you think about X and Y corresponding to the trig ratios, like we said up here, here that the trig ratios are with which X, Y, and R that corresponds to. If you want to add here, This is O over H. If you want to add it with OA and H to all of those, you can, but it's like your Y is your opposite side and your R is your hypotenuse. So thinking of it that way, you can see what your sine, cosine, and tangent would come out as, what sine, and they would all be positive in quadrant 1 because both the X and the Y are positive. Okay. Your R, your hypotenuse, is never going to have a positive or negative sign. It's just the X or the Y that are positive and negative, and going to determine the sign, the positive or negative sign of your trig. So in quadrant 2, sine is Y over R. And so because the Y is positive in quadrant 2, sine is positive. But cosine and tangent both use X. And since X is negative in quadrant 2, cosine and tangent both come out negative in quadrant 2. Okay, and you can see that pattern around in all 4 quadrants. So a little mnemonic to help us remember which trig functions are positive and negative in each quadrant is all students take calculus. Okay, in the order of your quadrants. So again, your quadrants are 1, 2, 3, and 4. So you go in that order and you say all are positive here. All students take calculus. So the A is for all the trig functions are positive. S is for sine, so only sine is positive in quadrant 2. T is for tangent, only tangent is positive in quadrant 3. And C is for cosine, only cosine is positive in quadrant 3, but all of them were positive there. So that's just a mnemonic to help you remember which trig function should be positive depending on what quadrant you're in. So in this example, we want to plot the point. This point is at 8, -6. So that's to the right 8 and down 6. So that's going to be in quadrant 4. I'm going to draw from the origin to there. Okay, so that's what we're going to label R. And then I'm going to create the triangle. So I went over and down to get there. I went over 8 and down 6. Make sure you label that as negative because you went down. I'm trying to put a right angle mark there. So I'm going to label then. We labeled R, and then that's X and Y. If you prefer to do OA and H, that's okay. And remember, this is the reference angle here. We can call it alpha. They didn't tell us theta. Theta could be the positive angle, or it could be this negative angle. That doesn't really matter because they have the same reference angle. They have the same reference angle. So we just really need to worry about the reference angle because it doesn't matter if we got to this terminal side from the positive or negative direction. The trig ratios are going to come out the same. So then we're going to go through and we're going to say, okay, so sine of theta, and it's y over r, but we need r. We don't know r, so we have to do Pythagorean theorem to find it. Okay, so you'll go to your calculator. Again, for Pythagorean theorem, it doesn't matter, but when you go to do your trig ratios, if anything asks to give your answer in decimal and you're going to put it in the calculator instead of just reducing your fraction, again, you need to make sure you are in degree mode. Okay, so I'm in degree mode. It doesn't matter for the Pythagorean though. So I'm doing 8 squared plus -6 squared. And this one's actually a Pythagorean triple if you don't realize it right away. It's your 3, 4, 5. It's just been doubled. So it's 6, 8, 10. But so this side comes out when you do Pythagorean theorem and work all of that out. This is going to come out to be 10. So your sine ratio would be the -6 over 10, which you need to reduce, and that would be -3/5. Okay, and it does say find the exact value of all 6 trig functions. So we want the reciprocals as well. So the reciprocal of sine is cosecant, and so that would just be negative 5/3. I just flip it. And then cosine is x over r, so that's 8/10, which reduces to 4/5. So secant is 5/4. And notice that one came out positive, which is good because in this quadrant 4, cosine should be the positive, and sine came out negative, and tangent should come out negative, which it will. So the reciprocal functions keep the same positive or negative sign, positive or negative value as their reciprocal. So if sine is negative, cosecant's negative. If cosine's positive, secant's positive. Now tangent is y over x, so that's negative 6/8. So that's negative 3/4. So then cotangent is negative 4/3. And so you have all 4 ratios. Cosine and its reciprocal were the only ones that came out positive because this was in quadrant 4. Okay, trying to get the screen to move up. Oh, there we go. For the sake of time, I'm going to skip example 3 because I think y'all probably get the idea. You're doing the same thing you did in example 2. We can go back over it when I'm back in class, and we're on regular schedule Thursday. But let's jump ahead to the it says if the values of one or more trig function and a quadrant on the terminal side of theta is known, you can find the other 5 trig functions. So this is similar, but instead of giving us a coordinate, they're giving us one of the 6 trig ratios. So they're telling us tangent, which is y over x. So they're telling us the y is 5 and the x is 12, which, okay, that could be because tangent's positive. Remember up here, tangent is positive in quadrant 1 and in quadrant 3. So this could be like a positive 5, positive 12, or it could be the fact that both the x and y are negative, and so it cancels out to become positive 5/12. So we're not just with that information. If you think about this, if you do the all students take calculus and you say, okay, tangent's positive, it's got to be here or here for tangent to be positive. You've narrowed it down to 2 quadrants. That's why they give you the second piece of information that says, well, sine of theta is less than 0. Sine is negative. Well, I know none of them are negative in quadrant 1. So we must be talking about quadrant 3 for sine to be negative, but tangent to be positive. So I'm going to draw my triangle in quadrant 3. And I know that the x is 12 and the y is 5. And then I would do Pythagorean theorem to find my r. And again, I believe you may or may not recognize all of your Pythagorean triples, but this one comes out as a triple, as the square root of 169 is 13. So this is a 5, 12, 13 that comes out to be. So then you could give your other 6 ratios from there. So we would know that sine is y. Man, it's giving me a lot of problems writing with my finger on this. Sorry, guys. Y over r. And so then cosecant be 13 over 5. Cosine. Oh, and I almost messed up there. We are in quadrant 3. We got tangent to be positive because both of these are negative. We went left and down to get here. This point right here is at negative 12, negative 5. So I need to make sure that I put a negative on that 5. and a negative on that 5. So negative 5/13 and negative 13/5. All right, and then cosine is x, so negative 12 over r, which is 13. So that means secant would be the reciprocal of that, which would be negative 13/12. Let me write what I'm trying to write. Come on, there we go. And then you already had tangent, so you just need the reciprocal, which would be 12/5. And that one was positive. So all of them came out negative except for tangent and cotangent because you're in quadrant 3. All right, and then you've got one more example like that. I'll let y'all give it a shot. But so we'll look over, I want y'all to try example 3 and 5, and then we'll go over and check them on Thursday. All right, so let me stop this video here and get it posted for y'all.